Hi students, today I thought I'd do a couple questions to help you review a couple topics. Here's number one. As part of their business promotional package, the Costa Rica Chamber of Commerce would like to estimate the mean cost per day to lease a one-bedroom apartment. A random sample of 40 apartments currently available for lease showed the mean cost per day was $323. The standard deviation of the sample was $25. Part A, develop a 98% confidence interval for the population mean. And B, would it be reasonable to conclude that the population mean is $350 per day? Now, this topic deals with estimation. And in particular, what we call a confidence interval estimate. Okay, we're trying to estimate mu, which is the population mean, and we do that by finding the sample mean, which is what we call a point estimate, and plus or minus an error. And again, this is x bar plus or minus, and the error is computed when you know sigma. It's known, is equal to z times sigma over root n. All right? We call this, by the way, the standard error. Now, to do this, we need to find x bar, and sometimes it's not given to you, sometimes it's given to you. So in this case, it's given to you as the average is the mean cost per day was $323. Plus or minus z times alpha over root n. Now, to do that, I know what sigma is. Sigma is equal to, where is it? $25. Right there. So I know that sigma equals 25. I know that the sample size is 40 apartments. And so I know this and I know this. The only thing I don't know is that. But we can figure that out. We figure that out by, first of all, figuring out that we need 1 minus alpha equals 0.98. We call this the level of confidence. Okay, the level of confidence, 1 minus alpha. In which case, when you draw it, I know that you're confident that this is 98%, right? Not percent there, 0.98, which means, right, that you're sure, they're pretty sure it's in here. That alpha is 0.02. The remaining, we call this the level of significance. Whereas this is called confidence. So I know that the significance is where you're not so sure, and it's at the ends. So if it's at both ends, we divide it up equally to be 0.01% at each end. All right. So I'm looking for alpha over 2, which is what that is, by the way. All right, which is 1% at that end and 1% at that end. So to do that, we either use Excel or we use our table. If we use our table, we do it differently than we do it with Excel. Since I'm looking for a 1% significance, I'm looking for the Z, I need to find 49%. The reason is because if you're using the table, then you know that the table in your textbook gives you this area here, right? So I'm looking for the 1% there. So if that's 1%, you look up 49%, all right, or 0.49. Whereas if you use Excel, the Excel commands give you the area coming to from the left going to the right. So the last, if you type in 3 standard deviations, for example, you're going to get 99.99%. So I'm looking for 1% here, and that's what you would use for Excel. Let's do both. So let's go back to the table. Again, I look up the green part, which is, in this case, our sample is, in our case, it will be 49%. So the closest I can come to 49% is going to be down here somewhere, right there, 4901.4901, which is 2.3. Go left, it's 2.3, and go up, it's 2.33. So let's go back. I know that this is 2.33 to be Z, right? Positive 2.33. If you use Excel, I can get the same number. Let's do that. So if I'm going to use Excel, this is what you get, right? You get this amount here, the 1%. So, which is done differently from the table, obviously, equals norm dot S for standardized, okay, dot inverse. So I'm looking for the Z-score, not the area. I know the probability that I'm looking for is 0.01. And this works out, as you can see, to be minus 2.326. But we're just going to round it to 2 decimal places. So let's see. So it's 2.33 negative. So let's go back. So you know that's minus 2.33, right? And this is positive 2.33. Same as this. So the table, you look up 49%. Excel, you look up the 1%. So let's get back to our question. So it's X bar equals 323 plus or minus 2.33 times sigma, which is 25 over the square root of 40. All right. Let me erase the rest of this so that you can see better. So X bar, not X bar, sorry, that's mu. Mu is equal to 323 plus or minus, and we take our calculator and we compute that. So let's actually use Excel. Equals 2.33 times standard deviation 25 and divided by the square root of 40. 9.210. So I know that this is 9.210. Let's just make it 9.21. So that tells me we have an error of $9.21. So the average rent, population rent, right, is somewhere between 323 minus 9.21, which is $313.79, and also 323 plus 9.21, which is 332.21. So I'm pretty sure that the population mean is somewhere between those two numbers. And that's how you do that. Part B says, would it be reasonable to conclude that the population mean is $350 per day? And I would say no, since it's not between those two ranges. All right, let's do the second question. A manufacturer of window frames knows from long experience that 5% of the production will have the same type of minor defect that will require an adjustment. What is the probability that in a sample of 20 window frames, n equals 20, right, and p equals 5%, or 0.05, what is the probability that a sample of 20 window frames, A, none will need adjustment? So you're looking for the probability that x equals 0. All right, and B, what you're looking for, at least one will need adjustment. So you're looking for the probability that x is greater than equal to 1. At least 1 means the lowest number is 1, so it's anything greater than 1. 1, 2, 3, upwards until 20. Actually, the maximum is 20. So you can also write this as the probability that is between 1 and 20. It's the same. It's greater than 1 to a maximum of 20. And C part, more than 2. So more than 2 means the probability that x is greater than equal to 2. And in this case, that's the same as the probability that it's 2, between 2 and 20. So greater than equal to 2 means including 2, greater than equal to 1 means including 1. So if you look at this, you'll notice that it's a discrete number of things that are happening. It's 20 window frames. You're not going to have 1.1, 1.2, 1.3. You're going to have 1, 2, 3, 4, up to 20. So it's a discrete probability distribution. And also, since we know it's 5%, it's the same always, and you know exactly how many window frames that you're testing, this must be a binomial probability. So there's two ways of doing this. You can do it with the formula. The formula will take, you can only do the formula with the first one since it's exactly 1. If you do you can use the formula for all of them. However, it will take you a long time since the second one, B, it's you have to calculate it 19 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 20. And x greater than or equal to 2, you have to calculate it 18 times, 2, 3, 4, 5, up to 20, and add them all together. A lot of work. So we're not going to do it with the formula. We're going to use either Excel or our table. So part A. We know that n equals 20, p equals 5%. First of all, you got to see if if a table is available. If not, then you have to use Excel. Let's go to our table. Here's our binomial probability table, and n equals 20 is available. It's here, and 5% is here. So we look up x equals 0, and we find it to be 0.358 or 35.8%, 0.358. So the probability that x is equal to 0 must be 0.358 or 35.8%, right? We can also use Excel. If we use Excel, then we type equals binom dot distribution, bracket, the number of successes, 0, comma, the number of trials, 20, comma, the probability of success, 0.05, 5%. And do you want it to be cumulative? No, I do not. I just want exactly 0. So I put 0, or you can type false as well. And you see it's 0.358. B part. B part is greater than or equal to 1. Right? The probability that x is greater than or equal to 1, which means the probability of x equals 1 plus the probability of x equals 2 all the way up to the probability that x equals 20. So again, the best way to do this is to use the cumulative table, or you can use Excel. If you use the table, I'm looking for everything up to 20. In this case, our table is not cumulative, the one that's given in the book, because you can see the last one is 0. If it's cumulative, it should always equal to 1. So it's cumulative, you have to add these all up. So, which won't be too bad, because you want 1 to 20, 0.377 plus 189 plus 0.060 plus 0.013, 0.002, and the rest are 0. So if you add all of these up from 0.377, you will get your answer. However, it's easier to use Excel, so let's do that. So again, here's our Excel. We type equals binom dot dist dot. In this case, we use range. Range means that you're going to add them all up from one lower number to a higher number. So if you look at the prompts, it tells you the number of trials is 20, comma, the probability is 0.05, comma, and the range is from, well, I want it from 1, comma, up to 20, since the 20 is the last one. And you can see it's 0.6415. So this is equal to 0.6415, which, by the way, if you use the table, you have to add them all up. C. From 2 to 20. So the probability that x is greater than or equal to 2 is the same as the probability that x is between 2 and 20 inclusive. So if you use the table again, here's n equals 20, it's 5%. 2 to 20 starts at 0.189 plus 0.06 plus 0.013 plus 0.02, and the rest are zeros. So if you add up these numbers, you will get your answer. But we can also use Excel. Here's Excel equals binom dot dist dot range trials 20, comma, probability 0.05, comma, I'm starting from 2 and I'm going up to 20, and the answer is 0.26416. So this must be 26416, or about 26.42%. Okay, so the easiest way to do this actually is probably Excel, but that's up to you. Okay, and that's two types of questions that we should review.